Sorry about that. Okay, guys, welcome aboard. How's everybody doing today? So today I am here to give a talk on the magic of mushrooms and basically bring to light, hopefully, some stuff that you guys didn't know about the medical implications of this kingdom and the technological and architectural ramifications of our study here. In the past probably about 10 years or so, this group of creatures has started to come to the forefront for several different reasons. And hopefully in the next hour, maybe hour and 15 minutes, I'll convince you that this long-ignored kingdom deserves a little bit of attention because it is bringing to us some of the most user-friendly, economical, and sustainable solutions to a lot of the ills that drag our society down. So when I was coming up in Western New York and Buffalo, where we didn't really have, my family doesn't really have a whole long history of knowledge of wild mushrooms or anything like that, and my parents were totally freaked out about us bringing in anything from the woods and putting it into our mouth. So mushrooms, how I grew up, came like this. And this was pretty much the only example of mushrooms that I grew up with, so I had absolutely no appreciation for this, and probably a lot of you would probably agree with me that pizza mushrooms, as they're canned like this, probably not the best representative of a kingdom if you're trying to convince a group of people that these things are delicious. Because if you've ever had mushrooms out of a can, they're not. This is your classic pizza mushroom. And in all cases here, it winds up being the same basic agaricus mushroom over and over and over again, and there's a good reason for that. And that's because this mushroom, your agaricus, or this is the common mushroom, or the button mushroom is what they call it, this is not marketed for flavor. This is marketed for shipping and durability and ability to sit on the shelf for a while. That's what these mushrooms are good at. Yes, they'll deliver some nutrition, but they're not going to deliver the taste. The reason why these are the mushrooms we consider food is because we've gotten really good at growing this one type. And the reason why it's still popular is because it can ship from Pennsylvania to California and still have a week or two on the shelf. So as far as a marketer is concerned, this is a home run. If I can only convince you to buy it, then this is going to be a good business plan. And it makes sense that we're kind of successful at this. We've been growing mushrooms like this in caves underneath France for hundreds of years, and this is where the knowledge came from over to America, which brings us the mushroom growing culture that we have here today, which is still just button mushrooms. And so this is what mushrooming today looks like for those button mushrooms. These are compost mushrooms. A lot of people would call these poop mushrooms. You do need to grow these guys on some kind of substrate, and it just so happens that manure winds up being an excellent substrate for these guys as a whole, as a group. Now, the thing that surprises a lot of people here is that 1/2 of the mushroom supply in the world, these guys are so good at shipping and just storage that half of the mushrooms from the world come from one town in Pennsylvania, Kennett Square. And this is from one of their production facilities. If you go down to Kennett Square, it's just this warehouse after warehouse after warehouse with no windows, and you don't know what's going on inside until you recognize the major economy in this is mushrooms. So if you had pizza mushrooms or canned mushrooms in the past few years, it likely came from that town in Pennsylvania. And this demand for these mushrooms has been going up and up and up universally since the 60s. And this is because this is when we really started growing those mushrooms out of that town, and their marketing efforts really went worldwide trying to convince you of the deliciousness of their product. And so what we see is a corresponding increase in the sale, the consumption of these button mushrooms per capita going up all the way into the most recent years. But the issue is they're terrible. These mushrooms are terrible. I don't know if you enjoy them, but to me, this is like a prison sentence trying to put these things down your mouth. If you want the good stuff, you've got to go out into the woods. And that's where you're going to find the stuff that's actually delicious. And the good news is, if you know what you're talking about, there are some gems to be had in the forest around Rockland County and the whole Hudson Valley up into the Catskills where we do our mushroom hunting. This is my family's mushroom hunts over the past few years. We primarily go into the woods to get chanterelles, and the reason is because chanterelles, they're really hard to mistake for anything else. My family, my parents, Definitely not mushroom people. It just so happens that my lovely wife is Eastern European from Poland, and her parents from Poland live with us. And so as we go from our house in Jersey to our house up in the Catskills where we do most of our mushroom hunting, we travel as a troop, including Grandma and Grandpa. We've got the ancient knowledge coming with us. This knowledge has been passed down generation by generation. We go out into the woods and we collect mainly chanterelles. Another favorite we've got is the boletes. We don't collect anything with gills on it from around here, and we'll talk about that in a little while. None of us are starving in my family, so this is about enjoyment, not nutrition. So we're not going to take the big risk. We do have mushrooms that will kill you in these woods growing right next to those that are delicious. But all of these guys are pretty much part of the unmistakable, the fearless four, because they don't look like anything that's poisonous around here, really. And chanterelles, if you've never had them, if you get them at the store, because they must be wild caught, they're going to cost somewhere between $20 and $30 a pound typically. The cheapest I've found in the past few years is $17.50 a pound. That's because somebody has to go out into the woods, collect them, vet them as safe, and then get them to the store. Go.
So you got all that for free?
All that for free.
Oh,
Yeah. This one was probably about an hour in the woods. This one was about 2 hours in the woods. It depends on the day. It depends on how long, if it's been raining recently, if we're in the right season. Yes.
Why do the bell mushrooms smell so bad?
Why do the
farms?
Oh, the bell mushrooms? Well, because that species puts out a particular aroma that is. That and the fact that they're grown on compost, which doesn't smell so hot in the first place. All right, so as we go, so as you're going out mushroom hunting into the woods, you do need to know what you're talking about. Because some are going to be delicious, some are going to be fatally toxic for you. And so up here we see a bunch of pictures of the non-poisonous ones. And can't you see how easy it is to tell the difference between the non-poisonous and the poisonous to keep you and your family safe? Well, if you can't tell the difference from that, well, why don't we get to, well, my clicker is not playing. Why don't we get to our easy guide to identifying mushrooms? With easy guides like this, who's going to screw it up? Everybody. Everybody. And the problem we've got is that we've got two particularly deadly species around here. One's called the death cap, and the other's called the destroying angel. And both of these are going to be peppered in right along with the mushrooms you would actually get off the forest floor that are delicious. And this is why that generational knowledge is so important. Many of our families didn't come to this country with this generational knowledge, and those that did have lost it over generations. So it's no wonder why in a typical cohort study of Americans, most of them are going to be straight up mycophobic, totally afraid of what they're going to collect on the forest floor. And no way would we put it in our mouths. Well, why are these guys so poisonous? Universally, they're doing the same thing. If you've ever taken any biology classes, you know that what we need to do to respond to your environment is get into a genetic program, express some genes as RNA, that RNA makes proteins, and that becomes your response. If you can't make those initial RNAs, you don't get a physiological response, and you, as a consequence, don't get to do well in any environment. Typically, this winds up being fatal. And what the mushroom poison is doing for both the death cap and the destroying angel, both of these relatives, they're cousins in the Amanita family, what they're going to do is they're going to get to that RNA polymerase, the gene that's going to be the first step in gene expression off the DNA, and the toxin gets right in the active site and it blocks it. And so now this protein can no longer read your DNA, it can no longer make RNA, you can no longer make proteins, therefore it takes away your ability to respond. Your homeostasis is destroyed, and as a consequence, so are you. Both of these mushrooms, if you eat them for the first 24 to 48 hours, you have no outward symptoms. It's just nothing, you had a delicious meal. And then in about day 2 into day 3, you start to vomit. You start to feel really, really bad. By the end of that day, you're thinking about going to the emergency room, it's that bad. By the time you get there, your liver has died. And you will die tomorrow or the next day. And it has happened several times in the past decade or so in our area, even among families with the generational knowledge that we've been talking about. So it's worth being careful. When we go hunting, the last step before anything goes in a pot is Grandma shows up and does another pass over the entire harvest, and another third of that harvest hits the garbage. because we're not starving. It's just for fun. Why would we need to take this risk? So just be aware, this is something that's going to inspire you and put you out in the woods. I encourage you, please go too, but make sure that you know what you're putting in your mouth, because it's a dangerous game that we can play. All right. But if you're not into do-it-yourself mushrooming, which actually after that whole thing, I can understand why. Well, we've got whole economies starting to pop up in places like Whole Foods and others, where they are actually just coming, bringing those mushrooms to you. If you got the cash to pay for their effort, they are more than happy to deliver the supply to your demand. And as a consequence, what we see is these forest-based mushrooms, they have actually started to come up. There are a few of these forest-based mushrooms that you can culture, and we've gotten pretty good at culturing them. And you're going to find them at some of your better grocery stores. Oyster mushrooms are going to be right next to those button mushrooms right now. Oyster mushrooms are these guys right here in the green line, and from the 90s into about 2012, 2013, we've seen an overall increase in the demand for these. Why? Because they don't taste like button mushrooms. They taste like delicious honey. If you just cook them with some butter and let the flavor speak for itself, there's a sweetness that comes off of these things that's almost as good as a chanterelle. And it's worth the $15 a pound you're going to pay for those guys. Yeah, they're expensive. They usually sell them in like $6 chunks in the grocery store when they have them. And they're only going to have them sporadically. And one of the reasons is because oyster mushrooms don't ship like those button mushrooms do. So if you've got an oyster mushroom farm, generally there's a couple hundred miles between oyster mushroom farms, because you've only got about 200 miles or so to be able to ship them from your place of production before they go south on you. You generally have about 5 days to sell them, and so this winds up being an on-demand product. One that's going to store a little bit easier for us that we've seen on the market since the late 80s is just shiitake mushroom. And because this has been around for longer, we've got more culinary dishes surrounding with the shiitake mushroom. All of these are good on your plate, but there's other reasons to eat them. And that's because they're good for you. Mushrooms are good with weight management. We'll talk about one that particularly is my favorite that I use. It's good for boosting your immune system. Many of these specialty mushrooms that aren't the button mushrooms we're going to talk about, these are gourmet, eat them mushrooms. But we can get out of them is things like anti-cancer medicines. And a lot of our most potent anti-cancer medicines are coming out of these species. And it's also, we've also found that a lot of these are good at straight up killing viruses. Something that we don't have a good solution to in our hospitals. And so we'll go through all this evidence as we go. So the shiitake mushrooms, lentula. This is what they look like, and you've probably seen them on a plate somewhere. These have been on plates now for 2 decades or more. They grow on logs. They don't grow on compost. So as far as culturing them go, it winds up being a much cleaner thing. What I do to culture these guys is I take little wooden dowels, you know, the little round pieces of wood, I cut them into inch-long pieces, I drop those into a bag like that. They colonize. And then I drill holes in a log, and with a hammer I'm just pounding those dowels in. Bam, bam, cover them with wax, and about a year later you start seeing mushrooms grow all over that log. Logs are cool, because you do the work once, and then they keep putting out flushes of mushrooms for the next 7 to 10 years every year. You can come back to that same log and get your free crop. If you're into gardening and you've got a little shady spot, this is a good way to expand your collection here and get a little bit more experience. Pretty easy too. Well, those shiitake mushrooms are delicious, but they're also really good at killing HIV. They're really, really good at killing tumors. They're really, really good at anti-tumor, apoptotic response, that's anti-tumor. And so some of the molecules we get while we eat these mushrooms are also going into you and causing specific health benefits. In fact, there are some anti-cancers that are extracted directly from fermented cultures of shiitake that we use and market as pharmacological solutions to cancer. Shiitake mushrooms being one of them. Oyster mushrooms is another one of these, and I already mentioned this guy. When I was mushroom farming, and before I got to RCC, between me teaching at Brooklyn and moving to here, I spent a year up at our house upstate. I turned our basement into a mushroom growing lab. And I grew oyster mushrooms for that year while I was working construction, and I was selling them at full price, $15 a pound. I couldn't leave my driveway. I would have 20 or 30 pounds of this stuff and all the neighbors would show up. I'd have these Eastern Europeans driving from Brooklyn to my driveway to show up. My whole goal was to get enough production, about 50 pounds a week, to be able to go out and sell it to restaurants. Never did I even leave my driveway with this stuff. People were showing up to me. Yeah, you cannot meet the demand for these. This is not button mushrooms. This is one of those things where if you feel inspired and you want to get into just a low investment lab that's going to allow you to start a business, might I suggest oyster mushrooms? Because they are good, delicious, easy to grow, they're relatively resistant to contamination. This is oyster mushrooms. They are so easy. You just drop them with some wood chips in a bag. These guys also grow on wood, so you don't have the whole disgust of compost some people get to. And they're delicious. But, again, colorectal cancer. We've got active activity. Anti-tumor activity in human breast cancer cells. We've got, the biggest one here is not the cancer. What we've got with oyster mushrooms is an anti-cholesterol medicine. Lovastatin is your pharmacologic pill that you're going to get at the pharmacy to lower your cholesterol. This is where they get lovastatin. So if you simply eat a few meals of oyster mushrooms, not only do you get the delicious, but you also get the cholesterol lowering properties of that. This is your medicine as food and as direct a way as I can deliver for you. It is still good after it's been cooked, yes. In fact, all of these mushrooms, you don't want to eat them without being cooked. They have digestive enzymes in there. That's going to actually cause some stomach upset unless we break it down with the heat. So you want to cook every mushroom before you put it in your body.
What is the name of the
Lovastatin.
Lovastatin.
Statin. And statins is the general term that we get out of these.
I've heard mushrooms can be overcooked. Why is that? Are their proteins too strong to use?
They can't be overcooked mainly because their cell walls are chitin, and that is an incredibly robust molecule. It's going to, it can't be digested, and it's also resistant to heat.
You're saying, sorry, you're saying that the enzymes that are in the mushrooms cause stomach upset,
Yes. Yes. And even in the face of that cooking, these medicines, the statins that come out of these mushrooms are still viable to help you out.
cooking does not diminish that?
A little bit, but not to any major effect. It's a protein, so of course we're going to eat. Other questions before we go? All right, so this winds up being, a couple of years ago, the Food and Drug Administration redid their guidelines for the people for when you should be indicated for being on statins. And 10 more million people in America overnight were now ready to be registered as statins users. This is a solution that gets us away from the dependence on the pharmacy and into your kitchen. All right, so that's oyster mushrooms. Aside from the other effects, that being primarily cancer, we also have some activity against recurrent respiratory tract infections against this one. The oyster mushrooms. And these you can buy right now in most of the good grocery stores you see around. Then we've got maitakes. Maitakes are also delicious. And these, again, these are all food mushrooms that aren't the button mushroom, right? But with these maitake mushrooms, again, you grow them up in bottle cultures like you see here. They've got this kind of elephant's ear look to it. But when we come down into the effects, the maitakes, again, wind up being amazingly active against many different kinds of cancer. These extracts from these mushrooms are going to be doing us favors. We just have to recognize and allow them to do their thing for us. Then we get into another local that could be one of the most potent anti-breast cancer medicine producers we'll see in our lifetime. This is the turkey tail mushroom. We see lots of different versions of this style of mushroom around in our forests. Those are fake turkey tails, and they will not have the same effect as the Tremates versicolor that you see here. You see this color banding with the bright bands? That's the one we're looking for. And with that one that we're looking for, that Tremates versicolor, we've actually gotten this up in clinical trials for breast cancer and leukemia. And those clinical trials have come back successful. So this mushroom is going to be one where we'll actually be extracting pharmacologics directly from the mushroom tissue and then putting those in breast cancer patients because we see a reduction in symptomology, remission go up. Question? As we go and have this conversation, I'm shining up a few papers. This is just a quick Google search, what came up first, right? There are hundreds of other papers per example to back up my statements. And I invite you, please, to go right over to Google Scholar, which is where we have the scientific literature papers, and check my results. Educate yourself, understand this stuff, and then spread the word. This one winds up being one of my favorites, the reishi mushroom. Back in China, back in the day, they've been culturing this one, or at least looking for it for at least 3,000 years. 3,000 years ago in China, this one, the reishi, also called lingji in Chinese, this was for emperors only. They call it the herb of immortality. If you were caught with this mushroom growing on your property, wild or cultured, and you hadn't already told the emperor, shows up with a troop from his army, you get decapitated in front of your family, they steal your family's land, and they collect all the reishi mushrooms because that's for the emperor. What are you doing with that on your property? You were supposed to know. That's the level of active on this. And we've known about this one for 3,000 years. I found out about this one because I lived in Flushing for a while. And you get down in Flushing and there's a lot of Asian stores and a lot of Asian tea going on. And with just about every meal I ever got down in Flushing, there was reishi tea at the end. Or lingji tea is what they call it. And why? Well, this one has, again, massively anti-cancer potential. Massive anti-tumor potential. Anti-cancer potential. But it also lowers your blood pressure. As an adjuvant, not a replacement for your blood pressure medicine. But this one actually causes it to come down a couple of points. This one adjusts your gut microbiome. And if you're in my micro class, you know about the microbiome. What we've got with this is a prebiotic, not a probiotic. Something that you take that adjusts your microbiome, and it causes your microbiome to help you deal with blood sugar more effectively. Now, colloquially, myself, I've told you stories about how I cycle between being kind of heavy and not exactly not heavy, but lower, right? And we go back and forth and back and forth. But one time, I had gotten up to 295 pounds. I was a large dude, right? And I was coming up the stairs on the first floor and just out of breath in the entire thing. And this was probably about 10 years ago. And I got tired of this. So I decided I'm going to do something for it. And now this is why I don't have exact evidence that it worked for me, because I did two things at once. I started taking reishi every day in capsules, about 1 gram. And I also dropped all the soda out of my diet. Because I was a soda chugger, man. 2 liters in a night was nothing for me. And so I don't know how, but over the next 4 months, it could have been the lack of soda, it could have been the reishi. Just like most things, science is probably a combination of the two. Dropped 60 pounds in the next 4 months, and I haven't gone back. I haven't gone back. And I would like to think it's because of that microbiome management that I'm talking so much about on campus every single day, all day. James?
Do you still take the reishi every day?
I do, indeed, yes. In fact, now I got tired of buying it, so I grow it.
Smart man.
I got 2 forms.
Cost efficient.
And all I do is I grind this stuff up, a little bit of a scale, and put it in the coffee. That's it.
That's the scale.
Yes, I can pass these around.
That's the scale.
These are all strung together. So I've got the club version where we get the medicine, and this is a fast-growing version where I haven't tried to see if
I was in the
that.
gym at like 3:30 this morning, right?
Yeah.
Have you brought up the chair?
Yes.
Yeah.
So I'm there.
What's that?
I wanted to max out.
I don't know, but I haven't gone
I
back.
get up.
You know what I discovered about the soda? Just as an aside, for me it wasn't about the sugar. I wasn't interested in the sweet. I figured this out later. I just wanted the bubbles.
Sweat dripping off this.
And so, seltzer. Like, I'm still drinking liters and liters of bubbly stuff, but now it's just seltzer. So, other questions before we
I got
go?
it after
Yes.
6 times. Like, but I literally thought I was gonna die.
It is an extract, it's a water extract, we've also got alcohol extracts that you're not going to get the benefit from. So what I like to do instead is grind it up and let my body do the extraction. But some people, when they put it in the tea, you get most of the carotenoids, which is out of the cell walls here, and that's going to be a good part of the medicine. But if you do an oil or an alcohol extraction, you get a whole other set of medicines out of this guy. And so really for me, I like to drop the whole thing in and just let the body take care of it.
So can I just, so you did something like that with castor oil or salt or?
Generally speaking, anything polar is going to work. Alcohol is going to be the hardest extraction, so that's what I use when I'm extracting.
Are these like non-edible?
This is a wood-growing mushroom that is woody to begin with. And so with this one, you really do need to grind it up and put it in some coffee. You're not going to be chewing on it. What you're holding in your hand is a mushroom that's now 5 years old. It's one I didn't grind. I can still grind it up. I'd probably see a decrease in the pharmacological activity that long. All right, the molecules would break down, but it would still be present. That's my example for this talk every. Other questions before we go?
Yeah, like when you can invite like people up that want some mushrooms.
I'm thinking about that. I'm thinking about putting together a workshop on stage. All right. Maybe not this time. Once the kids are a little older. All right, cordyceps. Cordyceps mushrooms, these guys grow on bugs. And what they're going to do is they're going to find a nice insect or a nice caterpillar. They're going to actually get the spore inside that creature while it's alive, and then it becomes a mind control creature. It gets up into the brains of these creatures and forces them to walk to an area that the mushroom likes, which is usually in the crooks of trees or someplace where there's lots of moss and lots of nice moisture. And then it kills the creature, and then mushrooms sprout out from the inside. Now we know about this mushroom from the Tibetan Sherpas, because in nature this one only grows above 11,000 feet in Tibet. And so the Sherpas, before oxygen tanks, you know what Sherpas do, right? They're the ones that are actually doing the work of climbing Mount Everest and these huge mountains. Well, what they would do before oxygen tanks is they would find these mushrooms on their way up and chew on them. Because it helps you deal with your oxygen more effectively, and it gives you more energy. You actually are making more ATP. So this one actually gives you a bit of an energy boost. And then back in about 2012, a group out of Britain decided they were going to give this to a bunch of geriatric patients to see if there would be the energy boost, but instead what they found was that people's arthritic pain was going away. And that's where this one starts to come to play now, not so much for the energy, which is still thumbs up, but now based on this group in Britain, what we're doing is we're getting into trials about how does this work with arthritic pain. And so far what they've found is that yes, it works. It does reduce your pain from arthritis. What they haven't figured out is why. They don't know if it's deadening the response from your immune system or if it's deadening the inflammation that causes the symptomology to begin with. But what they do know is that there is significant relief had by cordyceps mushrooms. And again, it's the same way. You don't have to start chewing on moldy caterpillars to get this job done. What you're going to do is you're going to take the mushroom, you're going to grind it up, put it in a capsule, and you're going to take it that way, or maybe even a tea. And so with these guys, the arthritis becomes a thing. So in degradation in inflammatory animal models, that's just basically big words talking about arthritis. Renal inflammation and oxidative stress. So now we're starting to get into more of the systemic stuff. Apoptotic pathways. So we got hepatocellular death. So that's liver cancer affected this. Post-ischemic treatment. So now we're talking about helping people with stroke. And so all of these wind up being brand new science. And that's why I give this talk every year. These papers that you're seeing, these discoveries that have been made, have been post-2005, most of them since 2010, so this is just not in the public sphere of knowledge. And the more we understand that these guys give us options, hopefully the less we'll be dependent on the systems that are failing us today. Lion's mane. This is another one. You get this. I grew this one for a while I was doing the mushroom farming thing. They're relatively easy to grow, and they got this shape that doesn't even look like a mushroom. But once you slice those guys up, put them with some butter and garlic in a pan, that's how I cook mushrooms. Just butter and garlic. Let the flavor speak for itself. That one tastes exactly like lobster. You're a vegetarian who misses their wonderful lobster. You can't eat shellfish? Well, here you get your opportunity to have the experience. And along with that, and when I tell you it tastes like lobster, I love lobster, this is spot on, right down to the texture. It's amazing. But that's not why they're so cool. They're so cool because they grow neurons. You take the extracts out of lion's mane and put them in your body, you actually have neurite outgrowth in your brain. So much so that this is on deck as an Alzheimer's treatment. It is in clinical trials currently. To grow neurons, to make you smarter, or to at least make you remember stuff. And for a lot of us, that's good enough, myself included. Along with your neural actives, we can't get through a conversation about the magic of mushrooms without talking about the one thing that winds up inspiring people is a conversation here. Now, I can't tell you how many times I've had to say, no, not that kind of mushrooms, when I say I'm farming mushrooms. However, in the past year, when I first started doing this thing and I had my website up and I was looking at other people's mushroom websites, every single one had a disclaimer. No, we don't do that kind of stuff here. Go someplace else. And I couldn't figure out why everybody felt the need to make that statement right on their front page. And then I started growing mushrooms and talking about it, and I understood. Because that's where people go, straight away. Well, why the hell are we talking about this? That's not the conversation we're going to have. Not here. You get to have that conversation someplace else. Over the past 2 to 3 years, since 2016, thank you to Johns Hopkins and the College of London, these two groups who have stuck their neck out, we now have some actual data of how these mushrooms could help you as well. It started out with Johns Hopkins. They did a very small study in 2016 where they took people who were dying of cancer. To get into this study, you had to be terminal and with almost no chance of survival. And what we were trying to do was just see, could we ease the depression, the anxiety associated with end-of-life issues in these last few months of these people's lives? And universally, the answer was yes. It was a controlled study in their labs. It's not like we're sending you out to the campfire with the kumbaya and everything. So what they did was they actually went and did the next week and 3 months later, and even after 3 months with a single experience, people reported a decrease in anxiety, a decrease in the depressive attitudes about these end-of-life issues, and overall, the effect was, I am at peace. Did
Johns Hopkins and the College of London do any study on that with post-traumatic stress disorder?
University of London just came out with some stuff last fall and backed it up with a reason why it might work in January. So this is all very, very fresh research. And the reason why we haven't had any research is because it's been classified Schedule 1 since Nixon, which means that you can't spend federal dollars on this. And if you do this study, you risk incarceration. And so you have to get all sorts of special permissions from the government to even ask these questions. And so we've got two groups that have asked that are asking the questions now. And the short answer is most likely. Yeah.
I've like researched this kind of stuff. Hey, I heard it decreases your fear responses.
It does.
Is that really what leads to depression and anxiety and all that?
That's the idea. But again, to pin a mechanism is going to be way premature, but we can talk about correlation. And what we think a correlation is a decreased fear response. All right, so we've got this with a life-threatening cancer. This is the quorum of papers that were associated with those studies. And then we've gotten in the past year, published last spring and right up until a couple of months ago, we keep getting papers for this, where we can actually think we can treat depression this way. And the reason why this becomes a benefit, and I understand we're talking about illicit substances here. The conversation I'm trying to have is maybe we want to reconsider the Schedule 1 denotation on these guys, because there could be severe benefit. This is treating depression that is treatment resistant. The people who are on the depression study have already failed with other tries and other types of medicines and other types of therapies. And so this, with the rest of the typical supportive care, becomes a decent treatment, single experiences, lasting beneficial effects for months. It persists, and it doesn't deaden the emotions. And that becomes, out of these studies, becomes the real kicker, is that we have effective treatment after minimal dosing, it's persistent, and we're not deadening you inside from the medicines. And this becomes, colloquially, from the people who are in the study, part of the best results of that study. And we think we even know why. What we've got is a serotonin system, and what we've seen in papers published in January from the University of London, fMRI, functional magnetic resonance imaging studies, which study blood flow to the brain after this psilocybin experience, magic mushroom experiences, blood flow to the amygdala is significantly reduced. And if you know what the amygdala is, this is your emotional response center. If you've ever dealt with a teenager having a fit over something that doesn't matter except for that teenager because they're having a freak out, their emotions are going crazy, it's because teenagers are known to have overactive amygdalas. That sense of maturity you're getting right about now into your 20s, that's because your amygdala is slowing down. It's not freaking you out as much. And what we've got here is a system that allows that slowdown to occur physiologically. And they think, and again, just thinking, we think that's where the effect, that's where it's rooted. There's a lot of work to be done here. This is going to land you in jail if you play with it just yet. But it's a conversation, it's true, this is one of the more egregious things that can happen to you. This is 40 times less toxic than alcohol. But, as it stands, this one is a risk, but it's time to start having the conversation. And that's why I included it in the talk this year. This is the first year I've done the magic mushrooms thing, but the research is now strong enough, I think we can start having a talk about it. Yeah?
So, it doesn't, like with pregnant women, is that something that they say if they are suffering depression or postpartum depression?
The issue in the postpartum depression, especially if they're not breastfeeding, I'd say maybe you want to try it out. The issue is with the breastfeeding and with the fetal, you're going to have some crosstalk there. And do you want the baby having the same experience?
To stay mellow?
Just did that, did you?
My grandma would have just used whiskey, but that's just all right, does anybody have any questions before we go on? Go ahead. What's that? Because back in the day, there was no knowledge about this. We can get in all sorts of political conversations about why things are Schedule 1 versus not, and it really does, it seems, wind up being rooted in politics and ignorance. From my professionally unbiased opinion. But I'm one to actually tout the benefits of these guys more than they talk about the risks. All right, guys, with that then, because this is such a unique system, what we've got is this man, Paul Stamets, who is a mushroom guy from up in Washington. He's the mushroom patent guy over the past 5 or 10 years. Just a couple of months ago, he patented this, a composition of the lion's mane mushroom with the psilocybin extracts coming together for neuron growth. So this is illegal, but not so illegal, we're not revolving patents around it currently in the anticipation of it becoming legal in the next 5 to 10 years. We'll see how politics roll, but this is official now. And it shouldn't make any surprise to anybody that we're using these creatures for such a wide array of medical compounds. The biggest medical compound we've come up with in human history came from a cousin of the mushroom, and that's the mold. That's what gives you antibiotics. In fact, during World War II, when we were trying to increase the production of penicillin, there was a huge nationwide thing, send us your rotten melons. And people would actually box up their old melons from their kitchen and ship it off to various centers, and what they would do is take those melons and grow them. Actually, they let them rot to grow the mold. That's how we got enough mold to extract enough penicillin to first feed our troops, and then upscale production to feed us with the antibiotics that we've been so overusing for the past 80 years. Right? This is Walter Fleming, and if you don't know the story of the discovery of penicillin, what this guy did, he's a bacteriologist. He had no interest in mold or fungi, and he had all his Petri plates one Friday night. Him and his lab tech were sitting there, they're kind of looking at the dishes, looking at the Friday night, looking at the dishes. Friday night wins. Leave them in the sink. We'll get them on Monday. And so they went off and had their weekend. They came back a few days later, Monday, now it's time to actually get the dishes done, and what they found was that mold growing in their bacteria plates. But now, what wound up being the kicker is they were smart enough to notice something changed. And they did what the most exciting sentence in science is. That's weird. which is, if you didn't catch it, the most exciting sentence in science. Because this leads to all sorts of other cool questions that then lead to things like penicillin. And so, penicillin. Well, not only are we getting antibacterial activity out of the molds that are related to these guys, we can take the mushrooms themselves, get those same extracts that we've been talking about medicinally, and from our plate, extract them. And what we've got here is viruses versus ribavirin. If they don't know what you've got, and they think it's a virus infection, but they think it's pretty certain that we better get that virus load down in your body, what they're going to do is they're going to inject ribavirin into you. We don't have specifics for viruses, many of them. And because you've got to get into some pretty heavy molecular biology and how to kill this thing that's inside your cell without killing the cell, that's a heavy lift. And so with ribavirin, we've got these guys right here. And those numbers are pretty decent, right? But then, when you take agarikon mushroom, that's this guy there. Or if you take that same reishi we talked about, that guy there. Or if you take chaga mushroom, this guy there. And we go into the 10 to 20 times more active against these viruses. It's a direct action versus what is the standard of care currently today for these. And so again, not only do I take the reishi to be able to lower my blood pressure a little bit, which in my family winds up being high, not only do I take that reishi to be able to adjust my microbiome as a prebiotic and hopefully keep that weight up, but I'm also taking it, particularly in the winter, because you all are nasty, you don't wash your hands, you're sneezing on me, and you give me flu, so no. I take this because whatever y'all expose me to, I get a little bit of an extra protection from it. This goes so far that we are actually feeding bees these extracts to deal with colony collapse disorder, and we're seeing 10 to 30% population boost instead of a complete crash in those bees that are fed these extracts, and we think it's because of a lack of viral load in the colony. Well, so far we've been talking about all the ways that mushrooms are really, really good for a creature. Well, we've come up with some ways that mushrooms are really, really bad for a creature. Remember that cordyceps mushroom I said liked to grow and eat insects and caterpillars? Well, that same guy who came up with the neural growing mushroom mix patent just a couple of slides ago came up with this. Entomopathogenic fungi. Entomo means insect, pathogenic means gonna get you sick. So this is fungi that are gonna get insects sick. And what this man's Paul Stamets does, the green here, this spot, that's sporulating. And that's when your bread gets moldy, get that green and the black. What they're doing is they're putting out babies. Those are the seeds. Those are like the apples on a tree. The white stuff is just the body of the mushroom, the mycelium. And what Mr. Stamets did was he came up with a way to get only the white stuff, only the non-sporulating mycelium, or body of the mushroom. He put that into a bunch of rye berries and put it in his daughter's dish and fed it to the ants in his house. They came back, they ate that mycelia, they came back, delivered it to their babies, delivered it to the queen back in the hive, and then it does what a cordyceps mushroom does. It grew through the bodies of these ants, and in the end, popped out a mushroom right out the top. Now we're back to sporulation form. And when sporulation happens, insects are terrified of it. Can you think about why insects might not like the smell of these things? Because if they get inside, they're going to be eaten from the inside out and then pop a mushroom off their head, only to get the next round out. So what this guy has done is come up with the perfect ant trap. One that attracts the ants to get them to that trap in the first place. It gets delivered out to the colony as a whole. We don't have to do this work. We allow the worker ants to do this for us. And in the end, we wipe out the colony that's present, and then the spores come out of that case and repel any new invaders. It works for years. As a consequence, we've got a patent on this one that covers over 200,000 different species.
Can you go back 1 second? Just 1 second.
Yes. So that's mycelia coming out of the ant's head, it's dead. And that's a mushroom coming up. Spores are going to come out of there. Christian?
Put a patent on living thing.
Yeah, I'll look at this. This is the whole game. Absolutely. We've been playing this game since the 90s. When genetic engineering came around, that was it. And there was a whole movement to just own stuff that they pretty much squashed. But we can't put patents on stuff. And so what this guy did was he put this. You might have seen this on social media. This guy owns a patent that could crush Monsanto and change the world. This one was making the rounds last year. Well, he does own the patent, but guess what? He opened it up to anybody. If you want to develop this as a commercial viable option, the patent is yours. Go develop it. It's too important. I'm not interested in the money. I've got enough money. You all will go take over it. I made the discovery. And so, for 200,000 commercial species, this has major commercial potential. And we can probably look forward to seeing something commercial based on this over the next probably 4 to 6 years being up on the market. It doesn't do it with chemicals. That's a beautiful thing. And once the first round is over, those spores wind up doing the job. And they get rid of other insects around your house as well. Yes?
So this have negative side effects to humans if they eat this mushroom?
No, in fact, one of the parts earlier was the same mushroom. You eat it to get anti-arthritis pain and a little bit more energy. So this is that same exact mushroom having a much different effect in a different group of creatures. Okay.
Well, I'm just wondering, so do you think this is the Richard Island?
There is some decent evidence about the reaching. I'm not so sure about the cordyceps. But that's really thin science still, so I don't want to stick my neck out. They have explored it because of the gut microbiota. They're working on it, but we're not there yet. That gut microbiota paper we just published in 2007. So this is all brand new science, really. Others? Okay.
Professor?
Yes.
So theoretically, so that can take control over the minds of like insects and other things. If you were to inject a spore into a human brain, would it have the complex,
No.
the capability?
The likelihood is absolutely not, because we don't have the same receptors. So we wouldn't have the same biochemical cascades to manipulate. That's why it's pretty much insect and arthropod specific. You'll get some spiders, you'll get some mites as well, but as far as our physiology, it really doesn't play the same way.
Okay.
Others? Okay. All right, so from this invention, that's my boy Paul Stamets, one of the heroes of my life. He got, if you don't know the American Association for the Advancement of Science, this is one of the foremost groups of science in the world, and 2 years ago when he announced that patent, he got to be one of the AAAS Science Innovators of the Year, which is one of the biggest, highest honors you can get in the scientific community. He doesn't have a PhD. He's just a guy who liked mushrooms so much that he got into it. He's got a master's degree in mushrooms, but after that he just owns his own company and he grows mushrooms for you and I. This is the man where I get my mushrooms from, because it is known that fungi perfecti has the best. You're going to pay for it a little bit. So if you get the stuff that's a little closer to the expiration date from Amazon, that's cool. It still works. But that's the guy, Paul Stamets. With all this cool stuff then, where did it come from? How did we get all of this incredible molecular milieus going on in a single creature? Well, they do also glow in the dark. We know that they've been around in the exact same form for about 100 million years. This is a mushroom cap that was discovered a few years ago in Burma that was dated to be 99 million years old. It looks exactly like the mushroom growing in the back of your house. So that means this has survived at least one mass extinction and still hits all of the same bells running 100 million years later. Well, from there we can go back a little bit further. This is Tortotubus. This is 440 million years old. This one was published about 2 years ago, just before the first mushroom talk I gave. This is the oldest land fossil ever found. 440 million years old. And what you've got here is not a mushroom. What you've got is the body of the mushroom, the stuff that grows in the food in the ground. That's called mycelium. The idea is that mushrooms, or at least fungi, were the first colonizers of land. Everyone came later. How could that be? It's because mycelia, especially with some species, are very, very good at biomineralizing rock. And that's what you can see here. All these threads, that's the body of a mushroom, which is actually these little tiny single-cell tubes called mycelia that grow all the way through anything that it's trying to eat. And you can see these crystals coming out, calcium oxalate. That is them digesting rock and turning it into food. So they have this ability with their amazing enzymes inside to digest stuff that you or I would look at and it's like, how can you even consider that food? These guys have that option because of their enzymes inside. And, you know, we see this today. Most of the time we're not going to see mycelia just growing on a rock. It's not good enough any longer. There's a better way. We can make an association with an algae. Let the algae make the sugar. I'll deliver the minerals to the algae. The algae delivers the sugar to me. This is a wonderful situation. It's a symbiosis. Everybody benefits. So today how we see this working is lichens, where you've got these blue lines are your mycelia, the body of the mushroom, these green dots are the algae, and that's what we look at. And you've seen this around, particularly on the north sides of trees, where it's a little wetter. Well, lichens grow in the little cracks in the rocks. Mycelia grow in these little micro pockets of moisture that you're going to see building up in these cracks in the rocks. And they biomineralize that rock. They make that crack a little wider, and then they die, and they leave organic material behind. And the next generation comes back and repeat the process, and then they die, and they leave a little bit more organic material behind. And for at least 100 million years, this was the process, leaving soil that then the next colonizers could take advantage of. And that would be the plants. But before you can grow a plant, you got to have soil. And we didn't have soil at first. Not before the grand molecular disassemblers showed up. This is Prototaxites. That's the mushroom body right there. 350 million years old. We discovered this in an African desert. I think it was Pakistan, actually, the Pakistani desert in 1956. This is another example in cross-section, but that whole sucker winds up being the mushroom body sticking up out of the ground. And what we think that actually looked like in artist rendition is this. The original mushrooms, 350 million years ago. But the thing to understand, look how big that thing is. The thing to understand is this is the apple to the tree. You all understand that the apples don't show up in the cart, right? They have to grow a tree first for a few years, and only after a few years of that growth will you get the fruit that you're looking for. For most of us, the fruit that we're looking for in the kingdom fungi is the mushroom. But just like that apple tree, that's not the big story of that creature. The big story of that creature is what's going on in the ground underneath. The mushroom is just a spore maker. The mushroom is the flower. The mushroom is there for reproduction. The mushroom is there to put out babies. And the mushroom, just like a plant, has a problem. It can't move around. So what it wants to do is it wants to make its babies in these mushrooms, but then it's got to send those spores out, those potential babies, as far as possible, because if my baby lands right there, same thing as if a seed lands right there, I've now got competition. And I need to kill competition for my own survival, which would mean I'd be fighting with my own kids. So just like trees use flowers and insects and birds to get their seeds spread as far away as possible, mushrooms have a similar style. Only, a lot of them aren't going to use insects. The mushrooms that smell like death, they smell like death to draw the flies, they cover the flies with their spores, and the flies go where they will, and now the spores are disseminated as far away as possible, right? Most of the time, what we're doing with these mushrooms is we're producing them in the gills, and then we're sending them wide. And these are the spores right there. By the tens of millions that they're made. Massive overproduction here. And all we did to get that spore print was take that mushroom, flip it upside down on a piece of paper for about 4 or 5 hours. That's how you get a spore print. The reason why the mushroom is above ground like this, it works just like an airplane wing. If you know how an airplane works, if you ever look really close at how an airplane cross-section is, the bottom is flat and the top has a hill. That allows the air underneath to keep going fast, but it slows the air on top. It creates a low pressure system right over that wing of the airplane. And things always travel from high to low, and so your airplane is not getting pushed up from underneath, it's getting sucked up into the air just from over top. From the shape of that wing and how the wind travels around it. Well, if you think about it, these spores coming down from these gills, they go south into the greater wind speed, they catch up here, and they literally get thrown into the air. That's why mushrooms have the shape that they do. Half an airplane wing. It's simply to cause this low pressure system that's going to drag these mushrooms high and send them as far as possible. Other mushrooms do it differently. Other mushrooms rely on things like rainwater and droplets to cause those spores. But every single little speck of dust that's in there is a baby mushroom ready to go. These aren't seeds, they're spores. And all we got to do is land on a nice wet surface with a little bit of food, and that's going to turn into mushroom mycelia, the body of these creatures. These are different spore prints, and one of the ways that when we're in the wild, if we've got a question about is this mushroom okay or not, is we can take a cap, flip it upside down on a piece of paper, and just wait a few hours and look at the color of the spores. The color of the spores that come out is a good indication of the type of species that you're working with here. And so between this and the actual physical characteristics of the mushroom itself, between these two, if you know what you're talking about, you pretty much have a good handle on what you're looking at in your hands, even if you have no idea. Okay. And this is what the spores are going to grow into. Mushroom mycelium. Single cell little threads that grow through. Mushrooms have the same biochemical requirements as us. They've got to breathe oxygen. They've got to eat food. They breathe out carbon dioxide. And instead of, like we do, taking small amounts, chewing it up real fine, and getting it into a central chamber for digestion, no. They're better at this than we are. They grow into their food, which means that there is no such thing as a bite too big. They can grow as long as there's food. And what they're doing is they're secreting their digestive enzymes into the environment, creating a soup, and then sucking in that soup. We can grow them in the lab just like this. All this is we took a little bit of a mushroom that we bought from a grocery store, cubed it out, put it on a petri dish with agar in it, and it grows. So this is really what we're dealing with these creatures. It's not the mushroom at all, but the mycelia that winds up predominating in the size and the function of these creatures. And this is what it looks like in time lapse. Isn't that gorgeous? I still do this stuff. If I got a mushroom I really like from the grocery store, just get some agar. You boil up some potatoes and put some thickener in it, and you've got your jelly for the bottom of the plate. And you just cut it and bam, that's exactly what it looks like. We've got 5 or 6 of these plates going this morning. I forgot them, so sorry. All right, so this can go for ages. In fact, the world's largest creature recognized today, discovered in 1998, is a honey mushroom forest. And the picture's not so hot, but you see how we've got forest and then not forest? That is a single mycelial mat that is 2,400 acres wide. We've done the math on this. We think it's about 2,200 years old. How do we know it's the same creature? We took a sample from that side. Well, not we. They took a sample from here, here, there. They drove in the middle, genetically all identical. This is a single mycelial mat. That's why they don't deal with the stomach system. Because as long as there is food, I can get bigger. I can have more mushrooms. I can make more babies. I'm more reproductively successful. This is the mushroom that's actually popping out of these guys. You can eat them. What it does is it infects a living tree, soaks all the juices out of that living tree for the first 7 or 8 years, kills the tree, and now it's got a straw down to the water table. It's never going to get dry. It's a beautiful system if you are the mushroom. Not so much if you're a tree on the top of that mountain. Slime mold is another one that grows very, very similarly. So this isn't a kingdom fungi, but it does use the same rules for finding food. And you can see how this thing is expanding, looking for new food sources. And this is a truism. If you walk through the woods, the mycelia underneath your foot, there's about 600 miles of mycelial threads in one footprint. And they jump up into your footprint looking for what you left behind. It's just you got to look and watch for a few hours to see that nobody's doing this. But these are disturbance species, and they're always looking for new food sources. Knowing this, the engineers in Tokyo actually designed the Tokyo subway system in a petri dish. And what they did was they set up one central hub. And what they wanted to do was see, could the slime mold do the math better than our engineers as far as delivering people on time more effectively? Can we get them to deliver a more efficient route than the engineers could? And so what we did was all these little white dots are little food spots. This is our inoculum right there. And you can see how this mycelia kept growing and growing and growing, finding these food spots. But then the amazing stuff starts to happen. They start pairing. You see how we've got all these tiny little micro extensions there? Those micro extensions start to pair away. They're wasteful. And this creature is not going to deal with waste. And so after just over 24 hours, this slime mold had totally rearranged, well, actually totally confirmed, with the exception of this top northwest corner here, totally confirmed what the architects and the engineers, with all of their calculus, took years to do. It took them 24 hours to get the same answer. And so here we have an intelligent system as well, one that can think, one that can do the math and understand what is best and most efficient. And this shouldn't be surprising, because mushrooms, mycelia, it can learn. We do learning differently. Granted, we have neural intelligence. We need experience, and that experience then gets a different neural connectivity, and that leads to memory, and that's how we get our intelligence. With these guys, all these green dots, those are nuclei. And how a lot of mushrooms grow their mycelia is they'll make a new cell, and then they'll chop the cell wall out from in between. So instead of cell by cell by cell, we get just big long straws. And what these big long straws allow us to do is stream nuclei back and forth freely across the entire network. That network then allows us to go into new food sources. Stream that nuclei with this nuclei with that nuclei. Each nucleus being a little bit different in the genes that it has, the potential enzymes it can bring to the fold. And so as these mycelia reach into a new food source, you see these nuclei streaming forward until the combination of these variable nuclei come together, which allows us a biochemical enzyme pathway to digest this new food, and it locks in. And now we've got a brand new system of biochemistry. That's why they're awesome. They're on-the-fly learning. And they don't need to teach the next generation. It's part of the DNA now. It's part of an innate system that's delivered to the next generation. And now this mycelia can generate and deal with that new food and digest it. Knowing this, we've come up with a new field called mycoremediation. Using mushrooms to clean up the environments we've spent the past 300 or so years screwing up. And the reason is because they have these special enzyme properties, and because they can mix and match their enzymatic capability. It allows them to, on the fly, be able to digest brand new things. So we can bring them to an environment, drop them in, allow them to eat what they're good at, and then allow them to expand into the stuff that we're not so good at chewing up. Let them learn and do the job on this. Mycoremediation. And so what we see here is mycelia on this side growing into engine oil. Growing in, and if you've noticed, actually digesting that engine oil. Engine oil is hydrocarbons, right? We call it fossil fuels for a reason. It used to be creature. So this has the same molecular characteristics as a lot of food. We can't get at it, but now these guys can. Using this technology, what we've got is now a way to deal more effectively with oil spills. A system was put in place. This was back in 2005, 2006. What they did was they contracted a bunch of companies, some with chemicals, some with mushrooms. And they brought our same oyster mushrooms. These guys. And they took about 50 of these bags and they worked it into oil-soaked dirt. So at 0 weeks, lifeless, poisonous. You're not growing anything in there, and if you did, you wouldn't eat it. After about a month and a half, all of that oil that was in there is being used as a nutrition source. And so they're breaking it apart, turning it into energy, and giving flushes of oyster mushrooms. And again, there's toxins in this stuff. So you're not going to eat the oyster mushrooms. You're going to leave them there. You let the worms eat them. The flies come and lay their eggs. You let the bugs start their system. Let them eat them, because that's going to bring the birds. And once the birds are here, they're going to bring the seeds. And once the seeds are here, that's going to bring the bushes. And when the bushes are here, that's going to bring the small mammals. And once the small mammals are here, now they're going to bring the bigger seeds. And this is remediation. It's bioremediation. This is the whole point. Take a poisonous environment and turn it back into a thriving ecosystem. This system does it in 3 months.
In 3 months?
In 3 months. Versus years on a classic bioremediation study. We'll get to that. Why aren't we using it? Because it's new. People don't know about it. That's why I give this talk every year. That's why. Because this stuff, unless you're plugged in, is not going to be common public knowledge. It's not as sexy as it needs to be on CNN. Yeah. Yeah. Talk to anybody who really is passionate about these creatures, and they'll be asking the exact same question you are, myself included. Money and drive. You need the drive before you get the money. And unless we can convince the public that this is a good idea, there's no way the public will convince our legislatures that it's worth the cash. So here I am. So, in a very real way, nature had internet first. And that's what you can really think of a good mycelial network as, a multinodal system that allows information transfer back and forth across the entire planet. And what we can do with this is we can take canvas sacks like this and grow this. And again, this is all it takes. Instead of in plastic, we put it in canvas. Instead of being 5 pounds, we make it 50 pounds, the length of this thing, and we just wrap it up and we put it in the waterways. The enzymes that are there chewing on those hydrocarbons are going to be doing their work here as well and decontaminate the water. When we're done, we pull this mycoboom out. It's contaminated. We sent that to a central location. We still have not yet gotten rid of the issue of the fact that this poison's in there, but the good news is that many of those toxins have been neutralized simply by the enzymatic action of these guys, and the others have been bioaccumulated in the mycelial tissues contained inside these bags, and we can remove it this way. Mycobooms is a thing. Sustainable solutions. And here we've got mycobooms going in and giving us some mycofiltration of agricultural runoff. One of the projects that Tri-Beta just got done giving a conference poster on this weekend is that these harmful algal blooms that are really screwing with our waterways. It's one of the biggest reasons why we're closing the beaches every summer, is these harmful algal blooms. Well, one of the biggest reasons they're occurring is because waste runoff from farmers' fields are increasing the phosphate too much inside those waterways. This is one way to remove a lot of that contamination before it hits the water. We go source instead of fixing. Prevention instead of cure. And with this, even in urban areas, we can start to get this. This is a park down in Florida, and what they've done is they've taken all of the runoff from this entire park, which is cut off over here, and they feed it all through a system looking like this. And inside here, we've got all sorts of mycobooms. So before that runoff from the streets, from the urban environment, goes back out into the nature, we treat them centrally located with mycobooms. We just replace the booms every couple of months. And it's a self-expanding system that you use agricultural waste for. This is rice hulls and corn stalks and the stuff that really just gets thrown to the back of the field as chaff or sold as such. We use this now as a value-added alternative for what would otherwise be waste from the farms. So we give farmers another leg up that they're going to need. We're going to keep sustainable agriculture going by giving them something, some place to sell their waste and turn it into a beautiful, functional system. And those enzymes don't really stop there. We don't have to think so large. We can just think, do you enjoy clean clothes? Because that's what your triple action is. Water detergent is different than the rest of your soaps because inside there are functional enzymes, and many of those enzymes come directly from kingdom fungi. Protease to deal with your blood stains. We've got amylase to deal with starch and carb stains and whitening boosters. We've got cellulase to deal with the grass stains, mayonnaise to deal with organic stains, and lipase to deal with fats. All of this is one of the reasons why your laundry detergent has to be so sticky. We actually add a stickener in there so this keeps those enzymes on top of your stains for a little bit while longer, and we get the chewing action happening. All we did was we figured out these enzymes in the creatures that use them to eat, and we said, well, here, we've got stuff for you to eat. I've got a whole pile of dirty clothes. You can eat all of the waste on that, and they do. That's why it works. Only triple action, microenzyme action, that didn't sell with people. So they had to come up with a beefier name, and so they call it triple action. But it's the same thing. And now it's more like 10 times action. Dozen action, because they've got dozens of these enzymes that they've discovered and add into there. And this is what the new formula usually is. A new enzyme that they've discovered in some mold or some fungi that now they've figured out how to extract the quantity and now they can put it in the formula. If you want to be a mushroom biologist, the applications of your knowledge are honestly limitless. All right, we've got other problems. to clean up. Now we go big again. Fukushima. Because building a nuclear reactor on a fault line was probably the best idea this century. And then we had the earthquake that caused the Fukushima disaster. If you don't know Fukushima, this area around the nuclear power plant in Japan will be 10 to 20,000 years before you're really going to safely occupy that space again. And that's not being melodramatic. The entire history of human civilization, that's what we need to wait before we can move back into those forests, as a consequence of what happened a few years ago. Now, we could allow that clock to just tick. We might be able to do something about it. And one of the ideas that has been presented about what to do about this thing is in about 80-kilometer range, 50-mile range from ground zero there, the Fukushima Dashi plant, we plant a forest of conifers with an associated gomphidius population of mushrooms. Gomphidius mushrooms, they don't mind radiation. Gomphidius mushrooms, they actually bioaccumulate cesium, which is the most egregious radioactive element coming out of that plant. And so we bioaccumulate the cesium, not in the mycelia, it pushes it up to the mushrooms, and it accumulates it there. So every year during harvest season, we just go in with a special crew, collect all the mushrooms, put the mushrooms someplace centrally located, because again, we're not dealing with that radiation here, we're just trying to pull it out of the ground. And it's estimated that if we can actually make that system work, we go from a 10,000-year clock to about 800-year clock. Still not going to matter to us or our kids, but hey, that's 10 times faster that we have a whole area of the planet that is inhabited. Pretty cool, yeah? And then what we're going to do with those mushrooms afterwards, we'll figure that out later, I guess. All right. And why do we want a forest with these guys? Because they need to be associated with a plant to actually do the job. In fact, a couple of years ago, 2015, there was a bunch of papers coming out that says that every single plant is part mushroom. You don't get successful plant without mushroom partners in the soil. And that's what we're looking at here. This right there, that central taproot, maybe this guy, that's the actual plant root. The rest of this is mushroom mycelia that is associated with it. It's called mycorrhizae. And what mycorrhizae do is they unlock the potential of the soil for your plants. They are trading mineral content of the dirt for the sugar content from the photosynthesis. Here you see the purple is the tree, the green here is the mycelia. And this happens over and over again. Most of that fuzzy is mycelia. And so if you inoculate your plants, what's going to happen is you're going to get mycelia possibly on the outside of the root, trading favors, or actually growing on the inside of the root, trading favors. But all in all, it's certainly a favor. If you grow with mycorrhizae, you're going to see a massive uptick in the production of your plants. I've been doing my tomatoes recently, getting them in my greenhouse in my basement here, and I've got this dust that I put with every single one of my seeds. It's called MycoGrow, and what it is, it's a combination of 4 or 5 mycorrhizal fungi that like associations with brand new tree roots. So if you coat the seed with this stuff, when the seed pops, the spores pop, they form this association, and you get more production out of your vegetables.
So is it like
No, it's spores. The spores in a clay solution, because the spores are so tiny, it allows us to actually see something that we're sprinkling on. A lot of seeds you can buy are going to say inoculated. This is inoculation. They're inoculating those seeds with mycorrhizal fungi. And so what we're going to get is a massive uptick in the production of these plants, because now that they get more nutrients from the soil, more minerals, they get more water from the soil. And all of this is simply because we've got an expansion of that root network 10 to 100-fold simply because of mycelia. In Florida, they did this study, a drought study on corn. And so mycorrhizae, mycorrhizae, no mycorrhizae, no mycorrhizae. Can you see the difference? And this is simply because the expansion of the root zone now allows deeper, more robust access to the water table underneath, drought or no. And a lot of my favorite mushrooms to eat come from the wild, and they cannot be grown any place. They can't be grown in the lab because they are mycorrhizal. Chanterelles, this is my favorite. In the Catskills, you're going to find it with beech trees. But when I go up to the Adirondacks, all of a sudden now I find it with pine trees and hemlocks. So we haven't figured out the secret mix between soil contents and the specific tree that it's going to go with, which is why we've got to grow these or catch them in the wild. There is no company that grows chanterelles. A couple of companies try morels every year, and again, these guys need to be mycorrhizal associated. We had somebody who said they figured out morel cultivation. He showed up to LA back in 1978 with a suitcase full of all his papers about how to grow morel mushrooms, and then his meeting with this big company was the next morning. Well, the cops found him dead in an alley that night. He got mugged. And he was the only guy who knew, so far as we know. So now 50 years later, we still have no commercial morel production. Although people still try, we still haven't gotten it figured out. And that's why these are so rare and so expensive. They have to be caught out in the woods. But just as a reminder, if you're out in the woods looking for this stuff, we've got poisonous ones. And in case you screw that up, we've got a solution for you too, from mushrooms. This is the infinity suit, where instead of fixatives and a coffin, we do a straight ground burial, and we wrap you in a shroud that has been inoculated with spores that are going to eat you. We return you to the earth even quicker. This is the green burial movement, and it has actually taken up quite a bit of a run for the past few years. She has a TED Talk if you wanted to get more information. She's a whole 15-minute talk on it. And it's the infinity burial suit, and basically what the idea is that you decompose. You recycle your matter back to the nature as quickly as possible. From my worldview, this makes a whole lot of sense versus holding on to something I don't need or infinity. I never understood that part. The other way we could get this is a group out of Italy who takes the same concept and they give you at least a little bit of a barrier between you and the worms, and they give you the burial pod, which comes with your favorite type of tree on the outside and all the spores that you would need on the inside. And so the idea is we bury you like this instead of our current means, and when we go visit our loved ones, it becomes more of a walk like that.
I prefer that in the tombstone.
Oh, absolutely. For me, this is it. This is my Saturday and Sunday every weekend, already. And speaking of getting rid of the old stuff, we've got a lot of plastic. And that plastic is killing us. We're currently choking on this stuff right now. Literally, choking on it. And a group in Yale, a couple years ago, went down to Ecuador looking for solutions to the plastic problem. And what they found was Pestalotiopsis microsporum. It can survive exclusively on polyurethane. This is a brand new discovery. Exclusively on plastic. That's the only thing you feed it. And it still thrives. Better than that, it doesn't need oxygen to live. It's a facultative anaerobe, which means that we can inject these spores to the bottoms of landfills and deal with 80 years of plastic buildup. We don't need to drag it out. We can just allow this mushroom to do its job in the landfill without uncapping it and kill the plastic. Eat it as food. And then in the end, that carbon goes back to bioavailable stuff. And we can actually support a food chain this way. Well, while we're busy getting rid of the old plastic, it might not be a bad idea to get rid of the plastic production altogether, and we're doing that as well. Mycelia is the new plastic. And last year, one of my independent research students did this project, and it won the Sustainability Prize for 2017. All we have to do is take that same agricultural waste we were talking about, put it into a form, seed it out with some mushrooms, give it a week, and you've got yourself a perfectly formed piece of plastic. Now this one, we used oyster mushrooms. Next time we go, we're going to use some more woody reishi mushrooms to do this. But in the end, what you get is a fully moldable, formable material that does have the exact same crush characteristics as styrofoam does. So why do we need styrofoam when we can just grow it? And if we can grow it, this stuff doesn't last for 20,000 years in a landfill like polyurethane. You bury it in your garden, it's gone in 8 weeks. And it turns into lovely soil instead of poison. What's that? Yes, I can, but be careful because it is dried oyster mushrooms. It's kind of brittle. We got the species wrong when we did it last year. Fresh, they're really good, but dry, not so much. This is how the process goes. We just stuff this any shape that you want with agricultural waste, feed it with some mycelia, let the mycelia go. We're not trying to grow mushrooms. We don't care about the mushrooms now. We're letting the body of the creature do the work for us. Be the glue that holds this whole thing together. No toxic glues and biodegradable. And this is what IKEA has turned all of their flat box packaging to. Best Buy and Dell have also gone to mycelial-based packaging instead of styrofoam. Not 25,000 years outgassing poisons that whole time before it breaks down. No, a month and a half. And better soil as a consequence. We can also replace the insulation in your walls with this. It's actually got a better R value than your classic styrofoam insulation that's probably in your house right now. And it doesn't light on fire, which means it's flame retardant in your walls as well. We can also use this same technology to give us wood replacement. Do we really need to chop down a tree for that board when we can make a fully capable board this way? Do we really need to use toxic glues in our plywood when we can simply use a biological material to do the same job by itself? And that's what we're talking about with microboards. And with Biomason, a local company, this is a company called Ecovative out of Albany, or near Albany, Grand Island. What they're doing is they're coming up with whole lines of furniture on nothing but mushroom wood. We take sawdust, we apply the appropriate species of mushroom mycelia, let it self-assemble, cook it to kill the mycelia, and now what you've got is plywood with the same basic characteristics of classic traditional plywood and none of the toxins. And you can buy this stuff right now. You can go to the Ecovative website and make your order. That stool is about $200 right now. And these are the guys, Evan and Max. And they did indeed grow this headline. This was also, now we're getting into the architectural stuff. And I'm sure you've seen all sorts of different impromptu buildings made of things like old 2-liter containers and everything. Well, this winds up being very similar. You can take your agricultural waste off the fields, grind it up, put it in little bricks, and each little brick then becomes the next brick to your wall. This was a 2014 winning project for MoMA's Young Architects program, and this entire thing is made nothing of bricks, made of the same processes going around, and stacked up this tall. They kept it there for about 3 weeks, and their entire thing was about sustainable architecture. And absolutely, when they pulled this thing down, they dug it underground, and they came back the next year, and there was almost no evidence that that building was dug underneath there. It had turned back to dirt. Sustainable solution. That's what the kingdom fungi is offering us. All we really need to do is pay attention and understand what they're trying to tell us. They might not speak the same language, but if we try to do the translation, and enough of us are on board with this, we could certainly bring our society ahead just a few steps forward, because these guys are delivering solutions to problems that we've been asking for solutions for decades. And with that, guys, I leave you with words from my mushroom idol, Paul Stamets. Hang on. One of the more inspirational clips I've seen.
Mushroom mycelium represents rebirth, rejuvenation, regeneration. Fungi generate soil that gives life. The task that we face today is to understand the language of nature. My mission is to discover the language of nature of the fungal networks that communicate with the ecosystem. And I, in particular, believe nature is intelligent. The fact that we lack the language skills to communicate with nature does not impugn the concept that nature is intelligent. It speaks to our inadequacy of our skill set for communication. We have now learned that there are these languages that are occurring and communication between each organism. If we don't get our act together and come in commonality and understanding of the organisms that sustain us today, not only will we destroy those organisms, but we will destroy ourselves. We need to have a paradigm shift in our consciousness. What will it take to achieve that? If I die trying, but I'm inadequate to the task to make a course change in the evolution of life on the planet, okay, I tried. The fact is, I tried. How many people are not trying? If you knew that every breath you took could save hundreds of lives in the future, had you walked down this path of knowledge, wouldn't you run down that path of knowledge as fast as you could? I believe nature is a force of good. Good is not only a concept, it is a spirit. And so hopefully the spirit of goodness will survive.
Thank you guys for coming. I appreciate it. If you guys want to check out some mycelia growing, I've got some in bottle culture here about to go to fruit for me this week. I've got this guy about to stick some holes in that and make some mushrooms out of this guy this week. And if you wouldn't mind, please, the RCC mushrooms and the Rishis, please put someplace obvious so we can pick them up later. Thanks again, everybody.
Bye, guys.
You with?
Those are bacteria. The plastic eating mushroom is what they're doing when they're coming up with that.
Oh, it's a dental office. Bye. Oh, hey.
How are you?
I'm good. How are you?
Good, good.
If you didn't get the list, the attendance list, please make sure you do. I'm going to talk to you Wednesday. Both Wednesdays are going to go and you'll have I've got the PowerPoint slides and audio going on Wednesday. I've got the video on Wednesday. Those going out. I'm going to probably have you do that. We'll have that going on Wednesday as a class. How are you? I did look it up. I don't own a PS4, so I have no way to play it. I'm done. That's my jam. I'm done. All right, thank you. I have it so I can. If I'm not embarrassed, if you wouldn't buy it, I'll probably put it on YouTube. What's your name? Dave Carter. Pleasure meeting you. Awesome creatures.
There's some type of motions and I saw before. They grow in that.
Yeah, oyster mushrooms grow in straw. But these guys are growing in wood, and you can see on top I've got some straw mixed in. Straw for these guys is the easiest way to do it. That's how I used to grow them up. I did bales of straw, pasteurize, drop some seed. Not on a large scale at first. The beauty of it is to set yourself up, you need like $1,500, and you're ready to go. For a whole life, for the whole time. It's a lot of DIY. Which means that your startup cost is incredibly low. And as long as you know what you're talking about, right here in this area, we've got the Ithaca guy, and there's a guy in Long Island on the North Fork, and we've got a guy in Connecticut. So right in here, as far as like oysters go, you've got Buick Farms, which is starting to come up with theirs, but they're more of a butt mushroom facility. But you have a spot with demand, and there's 0% ability to make a supply. So as big as you want to get, you can get, and your demand is still over. and increasingly every single year as people know more and more.
Yeah.
That was my
People
own.
know the benefits of it.
And I know if you go on YouTube, there's a lot of people starting up and how to do all this stuff. That was my training, is YouTube when I was first starting this. And you've got probably 6 or 7 people in our area who decided, I'm growing mushrooms now, and now this is their full life. And families involved in it. The blue oyster mushrooms up in Ithaca is a family operation. The one in Connecticut is just one lady who just wants to show up. And that's how it's typically starts. You start in the basement, then you get a